Okay, so this activity is 8.3, a pattern of 4 triangles. You can use rigid transformations of a figure to make patterns. Here's a diagram built with 3 different transformations of triangle A, B, C. Okay? Number 1, describe a rigid transformation that takes triangle ABC to CDE. So we got ABC to CDE. So as usual, I already have my triangle traced. So I trace it out. I always write my points on it because it's always very helpful. So the first thing I would do to take it to over here to triangle CDE is I would translate B to D, because remember, translation is moving in a straight line. So that's what I'm going to do first. It runs up right here. Then after that, I'm going to rotate 90 degrees clockwise around center D, because this is center D right here. If you rotate 90 degrees clockwise, it winds up right on top. So that's all you had to do to get that one there. Okay? So I translated B to D. Okay, let me see, what did I do? I rotate 90 degrees clockwise about center D. Okay, oh, gotta push it up so you can see a little bit about center D, and that's how I got that there. Okay, so then it says number 2. Push it up just a little bit more so we can see number 2. All right, number 2, describe a rigid transformation that takes triangle ABC, so we're using to triangle EFG. So now we're going to take it from here down to here. Okay, so once again, you can use that very same sheet of tracing paper, line it up here, all your points on your triangle. And the very first thing I did, because remember, you can translate in a straight line, and that would just be a straight diagonal line. So I'm going to translate B to F. B to F. Okay, then I can rotate 180 degrees with using F as my center. So F is right here under there. So F. So I'm going to translate it 180 degrees. So that would be 90. And that would be 180 there. Okay? So what did I do? I translate B to F. Then I rotate 180 degrees. Remember, when you do something 180 degrees, it doesn't matter which direction, whether you do clockwise or counterclockwise, you'll still wind up in the same position. So either direction there will work. And I used F as my center. Okay? All right, so the next one says, let's say, it says describe a rigid transformation. It says describe a rigid transformation that takes ABC to GHA. So this is ABC again, and we got to take it to GHA. So we're moving it over here. The very same triangle that you had traced earlier. Okay, so all you have to do, let me see, I'm going to translate B to H, because once again, a translation, this is just in the same, a straight line, so I go B to H. Then, let me see, I'm going to rotate, I'm using center H, 90 degrees counterclockwise, because this time I'm going to go backwards. And it lines up just beautifully. So what the translated, I'm going to move it up here so you can see. I translate B to H. Then I rotated rotate 90 degrees. You always have to get the degree of the angle, the direction, which was counterclockwise. And what else form it? A rotation. We need our center over the rotation. So I'm going to say about center H, because that's the center that we used. Okay, so number 4 is not, we didn't have to draw anything, we just have to answer a question here. And it says, let me move it up here so you can see too. It says, do line segments, remember the line segments up here of AC, we're talking about these ones here, AC. What else we got? CE here. And what else? We got EG. Okay. Then let me see. We also have GA, which is right here. All right. And it wants to know, are all this, do line segments AC, CE, EG, and GA all have the same length? Yes, they do. And how do we know that? Because whenever you have a rigid transformation, the side lengths are preserved. So in other words, the side lengths will always remain the same. So as you can see, they're all the same, they're all the same corresponding side of our original triangle. So that means there are, when you do a transformation, doing a rigid transformation, the side lengths are preserved. So yes, they are all the same size. So you could answer yes on that and just say yes, because of rigid transformations, they preserve the length of the sides. Okay?